So we want to solve 3 log base 2 of x minus 1 plus log base 2 of 4 equals 5. So the first thing I'm going to do, I'm going to get rid of this 3 and put it on the exponent using the laws of logarithm. So now I have log base 2 of x minus 1 to the power of 3 plus log base 2 of 4 equals 5. Now that I have the same bases in here and here, I know that I can rewrite this as a product, log base 2 of x minus 1 to the power of 3 times 4, that must equal 5. Okay, so now I'm going to go ahead and claim that this base to this power should equal the argument of the log. So I'm going to rewrite this as 2 to the power of 5, or rewrite this as x minus 1 cubed. I'm going to go ahead and put the 4 on the left of it. Doesn't matter, equal 2 to the power of 5, which is 32. So notice that what I can do here, I can divide both sides of this equation by 4. So if I do that, let me go to the next page, I get x minus 1 cubed equals 2 to the 5th was 32, dividing both sides by 4. Okay. And now I know 32 divided by 4 is 8. So x minus 1 cubed equals 8. If I take cube root of both sides, or you could think of this as raising both sides to the power of 1/3. Either way, I will get x minus 1 equals 2, and adding 1 to both sides, x equals 3. So remember, with logarithm, I have to check my answer. So I'm going to go back to the original problem. And if I, let's see, the original problem right here. So if I plug that 3 in here, 3 minus 1 is 2. Log base 2 of 2 is defined. And so that answer doesn't cause me any distress. So that was a good answer, legit answer. Now, let's do an example that actually that I get an answer that will not work. Here's what I mean. Let's try 2 log base 3 of x plus 4 minus log base 3 of 9 equal 2. So like previous problem, first I'm going to get rid of this 2 by using it as an exponent. So this is the same as saying log base 3 of x plus 4 to the power of 2 minus log base 3 of 9 equals 2. So I have the same basis. There's a minus sign in between. I can use this, I can rewrite this as a quotient. I can rewrite this as log base 3 of x plus 4 to the second over 9 equal 2. Now I can claim that this base to this power equal the argument of the logarithm. In other words, I can say that 3 to the power of 2 equals x plus 4 to the second over 9. So 3 squared actually is 9. So let me go ahead and go to the next page. Go ahead and go to the next page and rewrite this as 9 equal x plus 4 to the second power to and that was divided by 9. So let's get rid of the 9 in the denominator, multiply both sides by 9. So I get 81 equal x plus 4 to the second. Now, if I take the square root of both sides, then I get, let me actually write different color, take square root of both sides. Now notice that on the left-hand side, square root of 81 is, since I have on the right-hand side, I have x plus 4, and I had x, this was a quadratic, then this becomes plus and minus 9. You must be very careful with that. All right, so x plus 4 equals plus and minus 9. Subtracting 4 from both sides gives me two answers. positive 9 minus 4 is 5, and negative 9 minus 4 is negative 13. So I have x equals positive 5 and x equals negative 13, and this is, this I cannot trust. So let's check both of them. Go to the, go to the main original problem right here. Notice that if I plug in the 5 in here, that doesn't give me any problem. 5 plus 4 is 9, and log base 3 of 9 is defined. However, if I plug in the negative 13 in here, I get in trouble, because negative 13 plus 4 is negative 9, and negative 9 is not in the domain of, log base 3 of negative 9 is not defined. I cannot, excuse me, I cannot have, I cannot take a log any base of a negative number. Okay, let's do one more. How about this time? Log base. So something as easy as, how about log, common log of or log base 10 of x plus common log or log base 10 of x plus 15 equals positive 2. Well, the bases are the same, so I can rewrite this as log base 10 of x times x plus 15 equals 2. So now I can claim that 10 to the power of 2 equals x squared plus 15x. So rearranging this, this gives me x squared plus 15x minus 100 equals 0. And that actually is factorable to x plus 20, x minus 5 equals 0. So x equals negative 20 and x equals positive 5. So notice that positive 5 is not giving me any trouble. I can plug it in for x here and here. However, negative 20 cannot be plugged in. Common log of negative 20 is undefined. So this answer is not working for us. We need to say something like does not check. Toss that answer. Okay, let me know if you have any questions, and thank you.